All right, so great. Today's presentation will be presented by instructor Steve Barry. He will take us on this wild ride to learn more about data science for robotics in the era of multimodal large language models. I'll let him explain what that means because I have no clue. But yes, I'm very excited to pass on the mic to Professor Steve Barry.
Thank you very much, Jose, and I'm so glad to see everyone here today. I recognize some friendly names, and please use the chat, speak up, whatever you want to do. This is just a way for us to have fun. I mean, I love data science because it's so exciting. It's so exciting to be what we're doing here and to work what we're doing. And today we're going to talk about a fun topic, which is robotics. And I really like robotics because I didn't really start off liking robotics. I'm a finance person. Here, maybe I'll put well, I'll keep my background off. But I'm a finance person. Yeah, what the hey, I'll put my background on. So I don't have a UChicago background here, but I'll put my work background so it looks pretty. Um, and I learn through play, and I want to have fun while I learn, and robots, drones are a really amazing way to get instant, fast failure, fail small, fail fast, fail frequently. That's what I love about robotics. So let's get into it really quickly. Um, let's see if I can make this work. If you've taken a class with me, and I can see a couple of people on the call have taken a class with me, you've seen this image. I just love this. I miss Chicago in the fall and all the excitement around the start of the campus and stuff like that. So I usually like to start my classes with this slide, and I'm still trying to find out who this one individual is. Let me see here if I've got this. So a little bit about me. Okay. So I'm a lecturer, I'm an instructor, I guess is the title. I'm a professor at the University of Chicago's Applied Data Science program. And I hope, is there any, just out of curiosity, anybody in the program or considering joining the program? Is anybody here to kind of get an idea? Okay. Okay, cool. I should have done surveys, right? And done surveys live interactively. Cool. And feel welcome to, go on camera, whatever you want to do. I like to see you guys. In any case, my day job has me as the head of data science and AI at this company called Savant, right? And Savant's a large wealth manager. We're in the RIA business. So, the largest in our industry is Charles Schwab, and I'm sure many of you have heard of that. And Savant is anywhere from, like the seventh to the 12th largest RIA. So, but hopefully our business plan will make us the third largest RIA in just a few years from now. And we plan on doing that entirely through data science and AI. Not entirely, but as a large pillar of our future advisory. A little bit about me. I'm the geek who loves the cloud. I'm the computer science person in the data science program. So I have experience in GCP, AWS, and Azure, and I love them to death. I am a graduate of the program, so I graduated myself. I was a pandemic baby. I graduated in June of 2020. I've been around the program for a long time, but really, if you know me, 97% of who I am is hanging out with my family and being close to my kids and my wife and doing things with them. And then there's this like 3% of me that is I'm a total nerd and I'm a total geek. And I love everything about data science and computers. And that's the part I want to talk to you today about is the 3%. So I have these robots here on the screen, a little bit more about me, my GitHub site. Please feel welcome to go to my GitHub site. I've got a lot of projects there on drones that anybody can take advantage of or robotics. But in any case, this robot, oh, didn't mean to do that. This robot, and I've got to learn that whole little icon with the pointer. But in any case, this robot was a robot I used when I was in school as a Go robot way long ago. Today, we're using these drones in our classes, these Tello drones. We've had great projects. I'll talk a little bit about them. And, coming up, we're talking about more high-end equipment. This Traxxas car, we can put a Pi on that, a Raspberry Pi, and make it do all kinds of cool things. So that's a little bit about me. Um, I mentioned I teach a class in robotics. So I just figure I'll give you a little background on UChicago. So we do have a capstone class. And if you're a current student and you're looking for a capstone, please sign up for my capstone. You'll have the best time and you'll probably do well. because they're cool and people love them. But in any case, in our capstone one, we cover a ton of transfer learning. We cover it end to end, stem to stern. We just try to apply data science constantly because ultimately, data science or AI is about giving machines human-like qualities, human cognition, human awareness, being able to see, being able to hear, being able to touch and understand, being able to reason. These are human cognitive skills. Data science is the discipline of giving a machine, a bot, software, a physical robot, giving it human-like qualities. Okay, so in our capstone one, we expect our students to be very in control of object detection, being able to do swarm and navigation. That's where we have many drones flying together or robots, to know sensor data, to do voice and audio detection, to complete a stage one mission, and to write a publishable quality paper that they can get published in archive or some professional journal of some kind. When we get to capstone two, my God, here, so they are doing 1, 2, 3 on their phone. They need to do all this in capstone one. They need to figure out all these things with their drone. In capstone two, we're looking for much higher level solutions with robotics. And I'm going to get to the multimodal part here. We're going to get to large language models. I'm just kind of doing a little setup here. We're bringing all this to bear. I'll make sure I'm watching my time. So I have a few minutes left for questions. But in capstone two, we build on what we did in capstone one. And we're really expecting people to have very fine-grained control of their robots. We're expecting them to build their own custom models, not use somebody else's models, but actually build their own. And there's a variety of ways we do that. They ultimately have to produce a project. And some of the projects that our teams have worked on is basketball analysis, real-time basketball analysis. It's the coolest project I've ever seen. I've got a capstone team doing that now. A group last year. Jose, did you ever see that one? Find My Dog?
I did not.
Oh my God, it's so awesome. Find My Dog's amazing. They've got 2 white labs. They look exactly alike. They're in snow. It's snowing out. And they trained their models when it wasn't snowing. I cannot tell these dogs apart, but they're describing you only look once, YOLO model. One of the team members last December was explaining this, and he's saying, there's 3 phases to our neural network. The first phase, we're looking at color and contour. So we see the shape and we see it's a dog. The second layer, we're looking at more higher level features like the texture of the fur. In the third layer of our neural network, we're looking at like very high residual features like the moisture on the nose, the air croppings, things like that. So I can't tell the difference between these dogs, but a computer can without a problem. And you see 86% sure that's not my dog and 92% sure that is my dog, and it blows me away. They're identical. I literally could not tell them apart. So a really cool project. I will try to post a link with those projects so you guys can watch them and see what we do here at the University of Chicago. What are our capstones? What are our crowning master's program achievements? What do we do with that? And if you guys are considering a degree here at UChicago, I mean, it's worked out well for me is all I'm going to say. So I highly encourage you to look at the program. One of the great projects we had last quarter also was American Sign Language. Somebody had a passion project and they had a translating robot that would follow them around and translate for anybody doing sign language. Really cute. Safe landing zones for helicopters. One thing that's been really exciting, which we're going to maybe do next year when we get GPS drones, little micro GPS drones, is do these really cool drone light shows, like have a angry dragon and a friendly dragon fighting in the air, something like that. And what makes that possible? Large language models, right? Which is why we wanted to come here today. So on to our topic of the day. What is the impact of multimodal large language models on robotics? And what is a multimodal large language model? I'm sure many people on this call are familiar with multimodal models because they're interested in data science. All right, so I've got a video for you here. What are robotics and multimodal? What is the importance of multimodal models? Let me see if I can flip over here, if I've got it right. I should be able to click on this and do this, but let me see if I've done it right here. Yeah, here we go. Let me see if you hear what I'm presenting. Do you hear that? Do you hear that? Okay. So is this the future of robotics for us? making us meals, being our nurse, cleaning up our spots. All right, enough of that. So what are robotics? Right? And here's a link to that one. Well, what is a multimodal versus a unimodal large language model? Unimodal means that we can accept one mode of input and we have one mode of output, right? So you guys all know what multimodal models are, and you do too, Jose. You go to ChatGPT and you can click the attach button. It automatically can read pictures, can read images, can read other things that GPT 3.5 couldn't, but 4 can, right? And they added that. A multimodal model is just that. It can receive instructions from a picture, from a text, or from anything. Like we've got multiple modes of input for this, and then we have multiple modes of output. So that's all multimodal means, but it's the rage right now because all the LLMs are now becoming multimodal. Originally, they were text-based, and now we're seeing more powerful multimodal models. So let's take another look here. And many of you probably saw this week or last week is Astra. Just by a show of hands or in chat, did anybody see Astra from Google? You saw it, you just don't remember it. Yeah, there they are. There they are. So I'm going to bore you guys with some of this. You've already seen this. But this is a multimodal large language model on a phone. Oh, I think I meant to start there. Here, I'll just jump ahead.
I see a speaker, which makes sound.
What is that part of the speaker called?
That is the tweeter. It produces high-frequency sounds.
Give me a creative alliteration about these.
Creative crayons color cheerfully. They certainly craft colorful creations.
What does that part of the code do?
This code defines encryption and decryption functions. It seems to use AESCBC and...
Okay, so you guys get the gist, right? That is a multimodal language, a multimodal large language model. And we're seeing them everywhere. Here, let's go back to here. And, at the end of the day, they can accept multiple modalities, such as images, text, and audio. This is going to have a massive impact on the field of robotics, on the field of everything, but the field of robotics specifically, which is why I wanted to point out multimodal models with robotics. So let's look at it a little bit. Right? What is a multimodal model? We've got a multimodal input encoding, which are we doing a text, image, audio, video. We just saw many of those forms. We saw audio, we saw images, and we saw text understanding. Text conversion just in that one Astra video, right? And there's others too. And it has a decoder or an encoder. It puts it into the LLM. And then we talk about semantic data, semantic understanding, and then we have the output, and multimodal models also have the ability to output in multi-modes. So, well, we'll talk more about that here in a second. And what are the benefits? We're going to go a little bit in history here, but what are the benefits of LLMs and multimodal LLMs? Why are they so important? Well, just, Gen AI and LLMs, they're creative application, time and cost savings, hyper personalization, enhanced efficiency and productivity, data synthesis. These are all tasks that a robot could do for us as well, right? And just to think about the field of robotics being deployed in this. And why robotics again? Because if you're doing a drone or you're doing a robot, it's going to crash, it's going to hit something. You want to, when you're learning, at least I do, I want to fail fast. I want to fail frequently. And I want to fail small. I don't want to fail large. I don't want to fail infrequently, and I don't want to fail big. Those are costly. Those are wasted opportunity costs. And a lot of times when you're learning data science and you're working with a customer, you're working with, it's not always clear the results. The results might take a while to come back. It might be fuzzy. It might not be crystal clear. The beautiful thing about a field like robotics is it's just a great way to learn data science. Like I said, I have zero interest in drones or robots. I have a lot of interest in finance. And I always tell people, like reinforcement learning. A different topic here, but what was the rage when I was in school was reinforcement learning. And reinforcement learning is just the concept of going through simulation and seeing events so many times that the computer has all possible outputs and knows what the best action is, right? So you simulate a video game. If you can teach a computer how to play a video game, by having the computer play the video game billions and billions of times, it's going to get better than me and you. But if I play the video game 10 times, I'm going to be better than the computer playing the video game 1,000 times. It takes a long time. It takes a long time to train these models. So you have to go through billions and billions of iterations to get them good. But in any case, using that reinforcement learning, how do I take robotics and apply it to finance? How do I take data science and apply it from one field to another? So, that's why I like reinforcement learning. If I can teach a computer how to play a video game like Super Mario Brothers, and I have a GitHub project out in there if you want to try this out, and I'm going to share that with you. You also have my GitHub site at the beginning. But if you can, let me flip out to that one actually really quickly here. I will do it. Let's just call an audible. GitHub. And oh, I lied. It's not Stevie B UChicago. I think it's sberry25. So I have two GitHub sites. Let's see if I got it. There's my son. Yeah, here it is. My son when he was 2. He's just so adorable there. So I play the game. If you can learn how to play Super Mario Brothers on a computer using OpenAI's Gymnasium, ironically, I did this presentation 2 days before the release of ChatGPT. If I would have done it 2 days later, I would have given them a presentation on ChatGPT and not reinforcement learning and stable baselines. But it's a simple game of if you can teach a agent, in this case, Mario, how to navigate the environment and record all their actions and see the outcomes of each action in a table so that the next time you see the exact same position, you look in that table and you're like, that Q table, and you're like, oh, here's my next best action. It's the one that did the best, and I'm going to use that. Using that same logic, that same models, RL-lib, stable baselines, the same notebooks, you can train a drone how to be autonomous. You can also train a car how to be driverless. I love driverless cars because they're doing the exact same work we're doing in our program every week, every day. But also, here's the tie back to finance. If you can teach a computer how to play a video game, you can teach a computer how to trade a portfolio on the stock market using the exact same models and methods. So again, drones are about learning through play, learning quickly, fast iterations. You don't have to like robotics, but you should like the field of robotics because it offers so much to us as data scientists. Okay. So, other things that LLMs are great at doing is reducing human error, minimizing costs, all things that robots can help with us as well, and drones can, robots. So I asked the question, what does ChatGPT think a multimodal model's impact on large language, on robotics? And they said, ChatGPT told me, this is ChatGPT 4.0, because I pay for it. And you should too. But multimodal large language models can have significant impacts on robotics because they enhance perception and understanding because we're receiving things in so many modes. They're improved human-robot interaction because now we can understand gestures and people and what's going on, and robots can respond to human responses. Right. So we'll talk about that when we get to healthcare and other things, because there's a lot going on here. Emotional support robot, that's a thing. Go to any senior living center. A lot of people are lonely, right? And a dog won't always do, or might not work. Autonomous decision making, scalability of learning. You know, what's funny is education. I don't know who here thinks education has to dramatically change because of large language models. Like, this is a field that hasn't changed since the 1860s. Thank you, Emily. 1860s, we're under the 1816s German education model, right? The one that produced Enlightenment thinkers, you know, right? And to challenge the feudal system, right? This model has been going on and has not changed in any really large fashion in 175 years, right? You know, college today looks like college when I went to college, and I'm older than dirt. Okay. It's the same. You know, it's not really any different. College has to change. Education has to dramatically change. It's elusive. It doesn't work for most. It's too expensive for many. And we're not educating, you know, the smartest. We're educating the wealthiest often, you know, right? So education's broken for most of the world. So I think that one of the fields that's going to totally be blown apart is the world of education. We have to really rethink what it's like to interact with technology. What's plagiarism? All these things are turned up on their head. Robotics is a fun field to explore some of this. But okay, so you know, what does a robotics company think about AI? So there's this company, Vtrix. It's in India, and they produce bots for a bunch of things, right? The main thing here is sensory perception. Bots have sensors, and there's a lot to do with that. So let me just make sure, check on time here. We're doing pretty good. I think we need to roll back the dice a little bit. Roll it back here and start a little bit more fundamental, okay? And then build our way back up. Okay, so what do you guys think? And you guys can put this in the chat, but what do you guys think of when you think of robots or drones? You know, I'm curious. No chatters. Asimov. Yeah, right? DJI, absolutely. You know, I think of Boston Dynamics. If you guys have ever seen the MIT Cheetahs, these things have been around for like 5 years. They play soccer. And then, you know, I think of the Ukraine and I think of, you know, the Middle East and Gaza, and I think of drone warfare, man. It scares the hell out of me. You know, by the way, I like the flying R2. I thought it was cute. But yeah, so a lot of people, Boston Dynamics, something limited functioning. You know, let me ask you this: is a chatbot a robot? Is software a robot? It's a bot. Yeah, I'm with you, Christian. Definitely. So, okay, you know, lots of robots out there, lots of definitions for what a robot is. There's autonomous mobile robots. They're often called AMRSs, automated guided vehicles, lots of acronyms in this field. Articulated robots, you know, an arm grabbing things, humanoids, things that look like that. Cobots. Cobots is the world of things that assist people. All kinds of cobots exist, but think in terms of health, wellness, in terms of mobility for people with disabilities. I'm sure you guys have seen some of that, some of the new technology out there, but we need it to be autonomous. Programming is not the way to go. And multimodal models will have an impact here, a huge impact. You know, we have industrial robots, surgical robots for precision. I had LASIK eye surgery done in, you know, like 20 years ago. A machine entirely did it. They programmed it in a machine, and a machine did it. It sliced off my cornea and it hit a laser inside of it and then flapped it back up. All done with a machine, because a human would make too many mistakes. So the future of surgery is overwhelming. But we're not talking about just robots. We're talking about autonomous robots, right? We don't want programmed robots. We want model-based robots. You know, mobile robots, stationary robots, a lot of different types. Service robots, army robots, astronaut robots, you know, and then like personal domestic, like the one that was cooking food, you know, making eggs, or cooking shrimp, I think it was what it was. You know, robots come in all flavors known to man. Is your home Puck? Is that a robot? I don't know, you know, right? If your Alexa devices, your Google Home devices, Are they? Roomba. Roomba, funny one on Roomba. Back to the reinforcement learning one. Back to the reinforcement learning one. So Roombas have sensors on the front of the Roomba, right? And so somebody tried to reinforcement learning train a Roomba, and they would get penalties if it hit the wall. So what the Roomba learned to do was to drive backwards. It never hit a sensor, just drove backwards the whole time. Did anybody see that? Awesome. So just a fun thing with Roomba. Yeah, my dishwasher, everything is a robot these days. You're right. That's so good. Such a good point. And you think we're going to have a few more coming. So, there's the exciting field of micro robotics. The ability to land, to plant a seed, to manage a seed. This stuff is real. There's all kinds of crazy stuff they're coming up with. These micro drones, this is how we're going to do our drone swarm light show. We're going to put a big LED light on this. We're going to put a GPS in here. And then what's going to happen is we're going to use a multi-shot example. When you're using an LLM, a zero-shot example is you just tell it, hey, fly in a pattern like a dragon. Okay, come up with the coordinates, come up with the GPS coordinates to make that happen. A single shot example is, here's an example of flying a dragon in this pattern. Come up with another pattern that's similar to this pattern. So I've given it a single shot example. A multi-shot example is, here's 25 ways or 10 ways to do a drone show. Follow this and come up with unique things on the fly. So what we're doing is we're putting LLMs in front of our drones, multimodal LLMs going forward. And we're saying, give me a drone show where I have an angry dragon and a friendly dragon fighting in the sky. All the LLM is giving back is GPS coordinates, three character coordinates, lat, long, and height, right? And pretty amazing what these things can do in real time, right? So a do anything drone, we're going to see a little look at that. So robotics. In this field of agriculture, is anybody excited about, I've been talking to so many people about agriculture. Everybody seems to love robotics with agriculture. Does anybody have a passion in that regard, or anybody, have anything that they care about with that? If you do, I'd love to hear it in the chat or just blurt it out. But, just a little bit more on drone classifications. So, you get to certain sizes where they tend to get licensed, right? You have to have, like, I think it's over 0.55 grams or whatever, 0.55 pounds. Anything over 0.55 pounds, and we need to license it and register it. So the explosion of micro drones and nano drones are coming out. But when we look at agriculture specifically, we've got robots, and you want these to all be autonomous. You want them to pick the right apple at the right time or pick the right peach at the right time. This is a company that actually is pretty popular out there. I think they're called Jensen. You've seen these little, they're different kind, but there's another kind. This is one that picks, but there's another kind that just goes up to an orange tree and shakes it, and out come all the oranges that are ready to go. Spot fertilizing, spot irrigating. Yields of farms have gone insane over time. Farm yields have gone insane, and we're on the next great farming revolution, where, we struggled more to feed our population, the global population, 150 years ago than we do today. But yet we have, I think, like 10 times the amount of people, and we're farming on less land than we were before because our yields have gone up so much because of technology. So when you look at the field of robotics and agriculture, we're expected to triple in the next 6 years from where we are today. And I think we'll exceed it, to be honest with you. But this market's in billions. So if you want to make money, I think Elon Musk has a thing out there. There's a meme out there that says, go into the lithium industry. Everybody's going to make money. Go into robotics. Every field is going to grow. So, looking at another field like medicine, right? We talk about co-pilots or cobots. A cobot is something that assists us in walking or doing things. And I think there was a minister in England, one of the MPs in England, that just had a bout with sepsis, and he lost his hands, he lost his feet, his appendages, and I'm sure he's going to be relying on cobots to help him going forward. We live in that era and that age. But surgical precision, putting care back in healthcare, doing little things like here, you'll see there's a task here of just like, the normal stuff we do to alleviate nurses and things like that. Exoskeletons, this concept of an exoskeleton and providing that for people with all kinds of bone and other disabilities. The supply chain, disinfectant robots, cleaning stuff. Just 5 years ago, this sounded like a joke. I don't think people are laughing today. We work with some companies that, at the university that we partner with, that run warehouses, and they're reselling services in these warehouses. So they rent out these large warehouses. I'll leave the company unnamed. And they're looking to build autonomous systems to sell back as products for when they when they rent these warehouses to like Amazon and, IKEA and other big providers. Can they sell them services like cleaning services, security services? And they're doing that all through robotics. So, and then pharmabotics, right? We don't want people doing pharmacies. There's a lot of management in the managing of the prescription drugs. So you want it's nice to have these things. And by the way, all this is from this one PhD doctor, MD, Bertland Mesko, who's I think really led a lot of the robotics field in healthcare. So we look at growth in robotics in healthcare. It's more extreme than agriculture. Oh my God, it's growing at 17% year over year. This is just in hospitals. So I don't know a field of robotics that is not more than tripling in the next 6 years. That's a lot. That is an amazing growth cycle, almost never seen in industries. It tells you we're onto something. So, expect to see a lot more of these. Okay. But I want to take you back even further. Okay. So we looked at what a multimodal model is, and we looked at where robots are today, where robotics are today. But let's talk about where we are in the greater scheme of society. Why does now matter? Why is now different? More so than just we have multimodal models. Okay, so here is my best version of the history of people and civilization on one slide. Okay, we had the Stone Age 2 million years ago. It led to the Bronze Age 3,000 millennium ago, 300 millennium ago, 3,000 years ago, or no, my math's wrong, 5,000 years, 5,000 years ago. We had the Iron Age, 30 some 100 years ago. And then nothing happened. That's why nothing really happened. I mean, there's some things that happened. I mean, you can give, credit to, the Persians in early civilization for coming up with algebra. And at the beginning of the 1700s or late 1600s, you have Newton and Raphson simultaneously working separately, one working in France, one working in England. We all know, Newton, the apple thing, dink. And they both simultaneously did not invent, but discovered calculus, right? The math, if algebra is the math for people, with algebra, we can figure out how to build a house. In 1700, we got calculus, the math that allows us to understand nature. If you look at anything in nature, except for crystals and some weird formations and things like that, almost everything is nonlinear. Look at you, look at a tree, look at that mountain behind me. It's not linear. Nothing is perfectly linear. It might look like it's linear, but it's not. Okay. People produce things that are linear constructed. Nature produces things that are nonlinear. So we got this amazing mathematics that was born out of necessity. We needed algebra 2,000, 3,000 years ago when we started in civilizations. We needed to build houses. We needed to build housing. We needed to know how much mud and how much sticks to grab, you know? And with algebra, you can, figure out how much drywall and wood you need to build a house. But we needed to solve the problems of nature. We started to enlighten ourselves and started to go a new direction. And so that led to the age of, the discovery of calculus led to the great industrial age. And you can say what you want to say about the industrial age. It ruined our planet, but it also changed our planet like never before. Prior to the industrial age, 97% of us were involved in agribusiness. After the industrial age, less than 3% of us are involved in agribusiness. We couldn't go anywhere. We couldn't get that food anywhere. We struggled to plant it. We struggled to manage it. We struggled to pick it. We struggled to cool it and preserve it. Food was very localized. This all changed with the steam engine. Water power is one thing, but I think the steam engine's the true thing. And the steam engine came about in 1830s. And the industrial age was, it then led to the electric power, the combustible engine. But ultimately, that real wave there took place from 1830 to 1930. It took 100 years to absorb the industrial age technology in the industrialized West and in industrialized Japan in the East, right? The global South and the rest of the globe industrialized over this period from 1940 to 2000. There is nowhere you will find somebody pushing a plow through a field with an ox. Almost everywhere we have mechanization in farming today and around the world, right? So we have specialized, and the industrial age has hit the entire population, right? So just kind of like how we got to where we got to, and it starts with that steam engine, right? That steam engine is what brought about everything. With the steam engine, we had railroads, we had tractors, we had steamboats, we had steamships. All of a sudden, the world got smaller. All of a sudden, we got to specialization, right? And you can look up about, where and how, but it basically started in England and Western Europe first. And so that leads to so many things: mechanization, migration to cities. I'm getting at something. This is related to robotics. Okay, I promise you. And we're in a great era today where we're seeing massive change that we haven't seen. It's not going to be as significant as the 1830s, but we haven't seen change like this since the 1830s. That's how significant this is. Enlightenment, demand for products, low farm wages. So farms got, people didn't make good money on farms anymore because we had mechanization. So they had to go find work elsewhere in factories and cities and stuff like that. So some people call this the 4 industrial revolutions. I don't really prescribe to this. I view them as separate, but going along with that line, you have the first industrial revolution, which is mechanical production, the steam engine and railroads. The second one was mass production with the advent of the combustible engine. The third one is automation, which is like the information age that started really after 1940s in the US and Tennessee Water Valley Authority with UNIVAC, that first computer, right? And now the 4th generation of the Industrial Revolution, some people will call AI. I combine this into one. I combine this into one. I think that the artificial age is way bigger, and I'll talk to you about this in a second, way bigger than anything we've seen before in technology, right? In the information age. Okay, and I have a reason to show you why it's impactful now, why it means something. But mechanization, electricity, automation, AI, same concepts, right? So what's the impact this has in the world? This is, by 1950, this is the post-1848 European map. Cities are starting to form and specializations occurring are early outcomes of the Industrial Revolution and mechanization. So what this map shows is that we have no peasant emancipation in Russia and most of the European South. There's no liberty. There's no, people are still enslaved, right? Basically in indentured slave, peasantry, right? But we see that manufacturing in the industrial base has really taken hold in the center of England, in the north of France, and in the center of Germany. And you see the large cities starting to finally get created, major cities 1820, major cities 1850, and you can see new cities are coming online all over. And that is directly as a result of mechanization. So what does this have to do with us? What does this have to do with data science? Okay, so let's look at the history of transformation. We talked about that one, right? The acceleration of technology growth. We've got the printing press. There's a printing press. Oh, not there. There's a printing press, right? 1400s, 1600s, we get a telescope. We get the steam engine in the 1800s. Here's a steam engine, right? And how did that lead to a multimodal vision transformer model that we have today, right? How did this go like this? 1900, 1950, the man on the moon, 2000s. Take a little look. So who's familiar with the person on the left? Anybody want to blurt it out in chat or just say it? It's Alan Turing. Yeah, there it is. Yeah, and Sam Altman. And my question is this: how did we go from this greatness to this mess? How did that happen to us? Okay, let's cover Alan Turing. I've never seen the book. I've never read the book. I've never seen the movie on Alan Turing. I need to do this. I know he's critical, but here's the deal. Alan Turing is the godfather, whatever you want to call that person. This is the person who started data science for us. This is the person who took us out of computational statistics and brought us to true insights with data. And he brought about heuristic search, right? The ability to search documents and how that was done. And he also is very well known for the Turing test, very good. And what famous World War II thing did he do? I know people know this. Yep, the Enigma machine. He cracked the Nazi code, right? So, we can thank World War II to Alan Turing. He was the one that cracked the German code. Now, here's a little aside. This is just more of a little bit of my personal views. So Alan Turing was a gay man. He was persecuted horribly during his time. He was chemically castrated by the British government for being gay. How terrible. And he did so much for that country and for all of us. Now, today, everybody has realized the mistake that happened in the 1940s and 1950s. Alan Turing is celebrated by myself and every data scientist I know as the godfather of AI. In addition to that, even the British realized they made a mistake, and they've since put him on the 50-pound note to celebrate him. So Alan Turing is celebrated posthumously for his great inventions. And it's these little shoulders. We climbed on shoulders to get to where we are today. Little shoulders got us to where we are. And so he kicks off the first AI boom, which happens from 1950 to 1973. We get a ton of new technologies. People are really excited about the field. We get a bunch of different work going on here with Simon, Newell, McCarthy, Minsky. A lot of things are happening. And then we go cold in the 70s. They just aren't interested in the work. And then a bunch of people in the 80s, like Feigenbaum and even, not Feynman, but like that crowd in the 80s was very excited about what's possible. And this was all born from neural networks were created in the early 80s, during this time frame by studying the eyeball and convolutional neural networks in the eyeball. And so our CNNs, our computer vision today, is largely driven by imitating the human brain and the human eye. So neural networks are just that, just like calculus is the math of nature. Data science is the statistics of nature, right? Of understanding the is the compute of nature of the brain. So, think of traditional computing and traditional BI as algebra, and think of data science as the calculus of computing. I'm sure that people have issues with that, but I'm going to run with it. And then we have a cold winter. Nothing happens. There's just nothing happening from the second AI winter on. There's nothing happening from 1988 until 2010. And that's where we kind of get to the Sam Altman and Satya Nadella crowd, right? How did this great man lead to this people? By the way, OpenAI should be called closed AI. And I think most people are now familiar with that argument. And you can't take a company that was based on sharing the data with everybody and then make it a private company right before you're about to go and make a bunch of money and take $500 billion. Well, you could say $150 billion of equity, and from a non-for-profit, just transfer it to a profit company. But with that aside, so we went from this greatness to this, what we've got now today. But how did we get here? What are the little shoulders that took us from 2010 to present? And I got to speed up because I'm running long here, Jose. I'm realizing that. Well, really quickly, AlexNet. Who knows what this person is? Does anybody know who this person is on the right? If you've taken one of my classes, you probably know who it is. It's Geoffrey Hinton. Geoffrey Hinton is what's called the godfather of AI at Google. We owe all of our modern stuff to Geoffrey Hinton for the most part. So Geoffrey Hinton took Feigenbaum's work, the convolutional neural network work of the 1980s, which was just dropped in 1988. Nobody ever did anything with neural networks. We got all excited about the World Wide Web. We got excited about cloud. We got excited about a bunch of other things. And we didn't get excited about this. So go figure, cloud comes about in 2007 with Amazon. By the time 2010 comes around, it starts getting exciting. This launches the whole age we're in today, which is it launches the era of big data, the era of data science. And it all came about because of cheap rentable cloud storage and compute. Don't kid yourself. That's exactly why it came about. So shortly thereafter, it allows everybody to experiment, to borrow computers, try them out, and give them back. Before, you had to build the peak capacity. Nobody could afford to do this. So cloud made this all accessible. Well, in 2012, one of the great things to pay attention to is this ImageNet Large Scale Visualization Recognition Challenge. It's very highly regarded. And AlexNet won that award in 2012. And does anybody know what AlexNet did? What it's famous for? It took a GPU and parallelized it onto two GPUs. So Geoffrey Hinton took a neural network and spanned it across two GPUs, graphical processing units, or fill programmable chips. At that point, that was the mic drop moment. Everybody knew you could now process all data through a neural network. It was just a computer engineering problem. We just had to get there. And this is how we got to ChatGPT, little shoulders. The next one is we get, Ian Goodfellow and his team produced GANs, General Adversarial Neural Networks. This is where one neural network is a discriminator and one neural network is the generator. One's generating questions and one's discriminating answers back and forth. So these are commonly used to get better results from neural networks. Well, think about it with large language models today. Has anybody played with like AutoGPT or God mode? Any hands for God mode? You should go look at it right now, godmode.com, and learn that one. This is ones where, we have two GPTs, chat GPTs, one's the discriminator, one's the questioner, and they're generating new knowledge amongst themselves. And this is maybe where you can start to say we're starting to approach general AI. So in any case, very cool what AutoGPT and God mode's doing. So basically you ask it a question and then it'll ask itself a bunch of questions about what the question you asked it for, so it gets the best answer back. So it's like, hey, I want to take a trip to Paris and I like these things. It'll fight with itself for an hour and come up with the best answer for you. So very cool stuff. Sequence to sequence learning here is the next one that came out. And this is where we, learn to understand sentences and break them down and what's the next best word. And, we start to get the next best option. ResNet, this is a Microsoft introduction. Residual learning is introduced there in 2015. Let's move on to BERT and beyond. Everybody here should know what BERT is, right? We'll get to that in a second. AlphaGo, that was the model that, go ahead, Geoffrey Hinton built. And that's why I have the Super Mario Brothers here. That's reinforcement learning. And they use DQNs and double DQNs, Monte Carlo tree search. And they use this to beat the best Go player. So using a neural network, using reinforcement learning and a Monte Carlo method, beat Go. Then here's the mic drop moment again from Geoffrey Hinton. Another Geoffrey Hinton moment. He writes and publishes the paper, Attention is All You Need. Attention is All You Need came out when I was a student. It is the paper on transformer models. When we talk about GPT, generative pre-trained transformer models, the T is for transformer. This was one on how to build transformer models. If you have not read this paper and you're planning on going into data science, or you're already in data science, go read this paper right now. It's one of the best things to read for you to explain it. A few years later in 2020, we get RAG, retrieval augmentation generation, which is often used for sending data to an LLM. But in any case, this is the paper what introduces LLMs. Transformer models, LLMs means the same thing. A year later, you all knew we got it, because in 2018, 6 years ago, you'd be typing in your phone or your Samsung. I'm sure you all had one, even if you were 16. And you would type, I will be, and the word home came up. That was using BERT. The first predictive text was BERT. And we started seeing BERT and all kinds of things, websites, all that stuff where it tells you what the next best words are. And it's the first implementation of Attention is All You Need. Following that, we get GPT-2 and GPT-3. GPT-3 was over 175 billion parameters. BERT was trained on 139 million parameters. BERT was trained on Wikipedia. Okay. GPT-3 is trained on everything it can get its hands on. And then in 2021, we start seeing new innovations like these are the multimodal models. These are the transformer models like DALL-E and VALL-E that do voice and image recognition. So look at today, all the models we've got out there. We've got GPT-4 trained on over 100 trillion parameters. BERT, 340 million, I guess not 100, 340 million. How small that is. GPT-2, 117 million. We're not even looking here at those new models that I just showed you, the Astra model and stuff like that. Some of the Gemini models. Gemini is amazing. It's got a 1.3 million token context window. Just mind-blowing. When we look at large language models and the landscape of large language models today, and I got to speed this up because we're way over, there's a lot of companies. Here's what I'm talking about. Why do you know that this time is different from any other place in the information age? Believe you me, mainframes weren't exciting. Those weren't exciting. PCs weren't exciting. Where we are today is exciting. Look at where we were in 1956. That's a 5 megabyte hard drive. This is a 1 terabyte drive in 2020. Okay. So if you think that anything, the exciting stuff of the information age is yet to happen. So I have this little thing here from Jensen Huang over at NVIDIA. Many of you guys saw this.
Yeah, right.
What do you think about AI? When you're thinking about AI applications and where we're going to see change in our lives, let's say over the next 3, 5, 7 years, where do you see that going? And in places where we will all potentially be affected.
You can hear this?
Our daily experience.
Yeah, first of all, I'm going to go to the punchline. AI is not going to take your jobs.
Everybody saw this.
The person who uses AI is going to take your job. Do you guys agree with that? Okay, so use AI as fast as you can so that you could stay gainfully employed. Let me ask you the second thing. When productivity increases, meaning we embed AI all over NVIDIA. NVIDIA is going to become one giant AI. We already use AI to design our chips. We can't design our chips. We can't write our optimizing compilers without AI. So we use AI all over the place. When AI increases the productivity of your company, what happens next? Layoffs? Or you hire more people? You hire more people. And the reason for that is, give me an example of one company that had earnings growth, productivity, because of productivity gains, that said, guess what? My gross margins just went up. Time for a layoff. So why is it that people think about losing jobs? If you think you have...
Okay, I just want to get that little point across, right? If AI is going to lead to productivity gains, it's going to lead to tons of new opportunities. Jose, do you think I can go a little bit long or a couple minutes long?
Yeah, go ahead.
Okay, so we'll get through this here. Traditional, single mode text or image or voice large language models. You've seen this. This is GPT-3. This is Valley-E, which is a neural codec language, or a diffusion model like Midjourney or Stable Diffusion or DALL-E. I do want to show you this. This is really cool. So this is
Imagine
yeah,
an environment.
I have it queued up so we don't have to watch that.
Robotic systems, unlike text-only applications, require a deep understanding.
My class, this was built by Microsoft they worked on this in December through February of 2022, 2023. And this is using a GPT model in the loop to build a do anything drone. This is what we're doing in our classes now as well. So the idea is that we can talk to our drone, tell it what we want it to do, and it does it because it has an LLM that can do reasoning and do coding on the fly.
Of the real-world physics, environmental context, and the ability to perform physical actions. A generative robotics model needs to have a robust common-sense knowledge and a sophisticated world model. Ideally, it would interact with users to interpret and execute commands in ways that are physically possible and are appropriate in the real world. To make effective use of ChatGPT for query instead of asking it to generate code unique and creative problem-solving element and library implementations, one that can adapt to different form factors and simulators, while allowing users to almost talk to their robots and get them to achieve desired.
Can you find something with sugar and a red logo?
Behavior.
There's the drone flying over here.
We architect this pipeline such that a robot behavior.
And it finds the.
We architect this pipe.
So that's work that we're doing in our classes. The same is introducing those LLMs to have an impact. Let me go. I think we're at the end here, so I'm not that far over. Enhancing multimodal languages. You know, it's all about why robots. It's all about sensors. Robots have sensors in them all over the place. You know, lots of advancements in human ability to do decision making. I'm just going to blast through this. The impact of multimodal learning on robotic adaptivity or adaptability. So, you know, robots can learn as well through human interaction, through reasoning, infers human actions, you know, senses the squeeze, you know, and the different models for doing that. Couple things, challenges in our future. Heterogeneity, they're not the same. We're dealing with different input types. They get confused often. Alignment gets messed up. You know, missing modalities. You're just not seeing it. And it's just more complex. So it's not like it's an easy field. But, you know, in summary, you know, here, we live in consequential times, which is why I had this. Today we live in consequential times. So, So today we live in consequential times. Lenin, the socialist, not the Beatle, you know, said about the Russian Revolution that there are decades where nothing happens. And then there are weeks where decades occur or decades happen. We are now in those weeks. We will see this adoption of technology. This won't take 100 years to absorb into society. And it's not going to be isolated in the industrialized West and Japan. This is going to be a global phenomenon that really we experience over the next 20 years. If you look back 20 years ago, we didn't have social media, like we didn't have Facebook. I've been corrected on this. Facebook apparently came out in 2004, so that's why I went back. I mean, that's why I went back 20 years. We didn't have social media. We didn't have big data. We didn't have cloud. We really didn't have data science like we know it today. And do you think the last 20 years has seen amazing inventions and discoveries and our lives have changed in dramatic ways? I would challenge you all this. Robots are a part of it, and robotics are going to start finally being immersed in our lives. But the reality is we do live in consequential time. What 20 years from now will look like will look dramatically different with exponential advancements. So this absorption isn't going to take 100 years and be isolated. It's going to be global and take like 20 years. And 20 years from now, the world is going to look completely different than it does today. So I'm sorry I went so long. I hope that this was of value for you folks and you had a good time. And I'm happy to stay around and just chat about the program, chat about anything you guys want to talk about.
Steve, yeah, well, we'll leave it open for the next 5 minutes to see if anybody has any questions.
And oh, here, I'll share out one real quick thing, because nobody's ever going to have questions. If you go to my GitHub site, not the Stevie B, this S. Berry one, but when I listed in the slide, Stevie B, UChicago, you will see that I have a number of repositories that directly relate to my classes, and you guys are welcome to take advantage of them and play around with these code and do whatever you want to do. There's definitely a lot of code in here, but specifically these correlate to modules, and they're pretty easy to learn and pretty easy to do if you want to get started. All right, good.
So I see that there's a question about the application process if you want to join the program. If you're an international student, unfortunately, the international deadline has passed, so you wouldn't be able to apply for the autumn 2024 start, but you could apply for our following start, which is the autumn 2025, and that application portal will open up in October of this year.
And those applications are due pretty early for international students, right, Jose?
Yeah, I believe they would be due, I think it's January 15th of the following year is when you would need to submit it in
So
by.
it's really the right time to start getting your application ready for next year, because it takes a while, just the visas and all that stuff.
Emily, you want to go ahead and unmute and ask your question?
You might have scared her away.
Yeah, I think I did. I see June 17th. Oh, what did that say? I see June 17th deadline as well. I just want to confirm. So so I believe it's actually June 19th. That is our final deadline for domestic students. So if you're a domestic student, you can still apply to the program for the autumn 2024. It's just for international students, just because of the whole visa having to wait for a visa, or if you're already here in the States but you're trying to transfer a CVIS, that takes quite some time. So unfortunately, you would not be able to apply for the 2024 term. And just that June 19th is the deadline for domestic students to still apply for this 2024 term. And if I could just confuse you, feel free to reach out to me. You can reach out to me by email. I'll go ahead and I'll put my email in the chat as well.
I'm going to put my LinkedIn as well for people if they want to connect that way or with email. Could we get that last GitHub link? Sure. And I'd be happy to even post the slide deck if you guys want it. I would have loved to have gone into coding and showing some of it, but it doesn't lend itself very well to a Zoom session.
Steve, I think there's a question here you could answer. Do you think data labeling will ever be automated rather than manually labeling out data, especially for images? And I mean, there's outsourcing, but it delays personal projects. Just curious.
Yeah, I think auto labeling exists today. So you go to any of the clouds, they have auto labeling engines for you. And we're using data science to auto labeling. Auto labeling is a nightmare and a pain. If anybody's taken one of my classes, they know that we spend a little time labeling pictures and putting bounding boxes and describing if it's a front face or a side face. But who was it that had that question here? I was just trying to dig it out here.
This is Christian. Can you hear me?
Christian. Yeah. Hey, Christian.
Yeah, the reason it's more of, I would say, one of the ridiculous projects I'm working on right now, personal, is data labeling my life in a way, but an ability to recall, like, let's say I was walking in the street. There's we're humans. We are creatures of habits. So just labeling everything, including humans, and in a way that would even be like, facial recognition systems, being able to say, oh, this person walking by here is John, based on the public information that's out there. That's kind of a bit scary. We're good more into privacy laws, but that's the kind of situation I'm trying to,
Yeah, well, the
look
privacy laws
into.
are interesting on that one, right? You don't have
Yeah,
privacy in public.
that's
You don't have
where.
privacy in public.
So that's where I'm
So,
like, that's why I made the labeling side where we could
so
recall, like
I'm
for
with you
example,
1,000%. Yeah. Sorry, I didn't mean to cut you off, Christian. What I was going to say is when I think of the field of data engineering, I think of large language models playing a huge role, multimodal large language models playing a huge role. When I want to take unstructured data and turn it to structured data, which is labeling the data, I would use a large language model for that. I wouldn't have a human manually do it. Now we have all these new tools. People are just, we're so exciting now because people are like building recipes with different AI, different data science techniques to get a solution. We really are in an era which I have never seen in my lifetime, and I'm super old, and will dominate your careers for your entire lifetime, your entire career, professional career. Everybody wants to think they live in consequential times. What's exciting is you guys do, right? And the auto labeling is just another factor of it. The idea, the concept of anything that a human can do, it's somewhat, there's complex tasks, but simple tasks of identifying and labeling, very hard for a computer to do, but I think we're there today. I think we're there.
All right. Well, I think
Good point. Good point, Raina on UChicago catching up with UCLA. Sorry, we don't have that. But by the way, I have dreams of ending up in UCLA. I don't know if anybody has ever been to Bel Air. Oh my God, there's no better place in the world. I mean, it's not the same degree, but it's definitely beautiful.
Yeah, for anyone that has applied to the program and that haven't received a decision, feel free to email me. If you just email me, let me know, and then I can go ahead and look at your record to see, why it's taken for a bit. So feel free to reach out to me, and I'll get back to you, everybody, usually by the end of the day today, if not early tomorrow morning, and we can go ahead and see what the issue is.
All right, this is a good group. They don't have a lot of questions. I don't think they were excited. I think they might have been bored with this presentation, Jose. I think we're gonna have to we're gonna spice it up a little bit.
It was great that I was able to so there's the movie, I guess it's Alan Turing. I saw a movie and I was like, this sounds very familiar to this movie. And then I looked it up and it was The Imitation Game. It was a really good movie.
I need to. Everybody's seen that movie, and I've been talking about Alan Turing in my classes forever. I really know very little about him, and I really need to probably sit down with a book on him and
Yeah, no, it was a really
just
good
get
movie.
in.
Cumberfield is the main character in the movie. He's Alan Turing. Very good movie. If you haven't seen it, definitely encourage you to watch it.
Yeah, definitely wrongs in society, but it seems like over time some of them get corrected.
Yeah.
Yeah, and my point with talking about Alan Turing and Geoffrey Hinton is, and I breezed through the Geoffrey Hinton stuff, but is that we didn't just get here by magic. We got here by climbing on other people's shoulders. And you know what? Here's something that I really want to impart to you all. I'm not saying this to be mean. I really want to be the one you love. I want to be likable, all that stuff. But with that said, nobody cares what you know. They only care what you can scale and document and share with others. So that's what the journey of science is about. It's about contributing back. And your work is worth publishing regardless of the state of where it's at. It's so critical that you publish your work because it's going to define you uniquely and for the rest of your career. And hopefully, like in my career at this point, I'm asked, like, what have you published? What have you done? And thank God I have a trove of students who are helping me co-publish with them, so I look like I've got a lot, but nobody cares what you know. And these people that were climbing on those shoulders, they made a decision to publish their work and to share it with others. Others have not done that, and science has been lost. Nobody cares what you know. Sorry.
All right, on that, we will end our session here.
What a terrible way to end. Oh, no.
Steve, we thank you very much for having this great talk. I encourage students, if you would like to learn more about Steve and what he's teaching in our courses, reach out. You can find him on LinkedIn, or if you go to our website, you can find any of our other events that we'll be hosting during the next couple of months. We actually will be taking a break from the data science seminar series this summer, but we will be back at it coming in September. So stay tuned and to see when our next one will be, or our next professor that will be presenting. So thank you all for joining us.
One thing, there was another question.
Day.
There was one other question I want to take on. Somebody said, what's my take on the future progression of data science and computational finance? Here's what I feel. Everybody's been predicting forever that technology is going to kill us. You go back to whenever, and it probably will. If you look at, I'm not a fan, but if you look at Elon Musk's companies like Tesla and SpaceX and Tesla Solar, they all have one mission statement, I think, which is to inhabit new planets before we destroy this one. Okay. And with that said, I am extremely bullish on society. I think that I'm so concerned. If you look at the previous industrial age, it led to the Gilded Age, which led to an antitrust age. The hyper concentration of wealth in a few hands, I think, is going to happen. I think there's going to be haves and have-nots because it's going to be intra-generational change, not intergenerational change. It'll happen within one generation. So that those people who are, that's why I did that Jetson Huang statement. If you're not using AI, use it right away, because it's not that AI will replace your job. It's somebody using AI will replace your job. And when I look at computational finance, I feel like it's not really going any, I mean, it's doing its thing. It's, definitely people are very excited about quantum computing and the concept of being able to store all known facts. But really, I think it's more the other way around. I think that everybody else is catching up to financial quants. So now we've got marketing quant, we've got health quant, we've got everybody's quants, because everybody wants to take in a million sets of data and make hay of it. So sorry to keep you longer, Jose, but I just thought that was a fun little topic.
All good. All right. Well, thank you very much for joining us today. Again, if you want to reach out, we will be welcoming your texts, or not your texts, but your emails and LinkedIn invites. So definitely reach out. Thank you, everyone.
Have a good day, everyone. Thank you.